Good morning, everyone. My name is Brian, and I am a student of the computer science in National University of San Agustin. At the start, the topic that our team are investigating is all about blockchain. Topics like cryptocurrency, consensus algorithms, Ethereum, smart contracts, etc. No? In this time, we will introduce you SimBlock. SimBlock is a simulator, as his name implies, no? It's an open source blockchain network simulator based in cryptocurrency like Bitcoin, Litecoin, and Dogecoin. This tool was developed by Distributed System Group in Tokyo Institute of Technology. SimBlock is available on operating systems such as Windows, Mac, Ubuntu Linux, or Unix, no? Platforms that support Java. SimBlock have a visualization tool. It's an event drive and suitable for use blockchain network research. Therefore, implies that we can easily change the behavior of the nodes so that it enables to investigate the influence of the nodes in the blockchains. No, SimBlock has a visualization like this. We can see the transition and the propagation of the nodes at the network. No, and this is a picture of the simulator. The blue dots are representing the nodes, and the lines are representing how it nodes are propagating for the network. No, when a color red means that the block has propagated for all the network. The color are changing constantly. We can configure the number of the blocks in one file. In this simulation configuration file, we can change the number of nodes, the algorithm that are we using, the interval of the generation of the blocks, the height of the blocks. For example, we can change 10, and we are generating 10 blocks on the chain. We obtained the output in the block list txt. Okay, back in this to the visualizer, to the visualizer, we can appreciate no how it is spreading no in all the network. Okay, this worked for me to learn no how the nodes are propagating with these parameters. We can configure different scenarios. No, we are talking about all these parameters and how it works. No, the nodes involved in the blockchain forms a peer-to-peer network. Transactions and blocks are routed for all the network. The protocol that this SimBlock use is very simple. It's just a send and response protocol. It's like we are sending a message, and the other node responds at us. No, the nodes participating in the network communicate periodically the obtained information of the nodes. The node selects a new neighbor node from this node information when a new neighbor is required. For example, we have now two nodes, the node A and the node B. The node A send a message to the node B, and the node B think and confirm if the block, if the node have no the block. If node B have the block, so send get data message to the node A. The node A responds with the block. If the node B haven't hasn't the the block simply ignore no that that message. Okay, in SimBlock we have 7 regions configured with their own approximate propagation times and bandwidths. These regions are no North America, Europe, South America, Asia Pacific, Japan, and Australia. These parameters can be adjusted to the user preference. We can add or we can delay no this list. The fundamental one pillar of blockchain is the mining. To simulate the blockchain and the mining process, we are using two consensus algorithms, proof of work and proof of stake. We can choose between one of the other, no, according our preference too. In simpler words, proof of work is like a race between a group of miners, no, trying to get a solution of a crazy mathematical puzzle. And the proof of stake, all nodes have a height, no, based in their cryptocurrency, and it decides his participation in the network. Okay, SimBlock proof of work, no? In this image, we can see the algorithm uses in SimBlock. It's quite simple, no? Each node have his own mining power, no? And the parameters we are trying to generate a nonce value that it's less than do no than this expression that we have in there. So we are trying to generate it. No? In Bitcoin, we have a hash. The hash is a value that begins with a number of zeros. So to simulate it in the blockchain, in the SimBlock, we are using a pow, 2 pow at minus 53, no? So the same in the same way, no? We have a similar scenario to proof of stake. Proof of stake use the class CoinH. This class CoinH simply, basically, is the number of the coins that the node has and the time he has them. The CoinH affects the calculation previously performed. If you have more coins, you have better chances to mint the block, no? We are using the same expression here. Okay, we are testing no blockchain in directions. It is a example of how it's working SimBlock. Okay, I change to the code. We are checking the blocks now. Okay, let me comment it. Uncomment it. Okay, for each occasion, we are trying to simulate a blockchain only in South America, no? Like this. Okay, I go to refresh it and run the program. When the program is running, generate in his code. Let me generate these files. These files contains the output, no? The output basically is the diagram in the visualization. We have the block list too, and we can find all these results on the network, no? Okay, we are simulating just a blockchain in South America. This is very more. I I do a bunch of these examples, and the average improve between 20 30% the time of generation blocks, no, in the network. This is because the upload and the download bandwidth is less, no, if in comparison with all the world. Uh, uh, all other some things that we can see is the timestamp. No, the timestamp generate the block propagation and the block creation. No, other example that we can take is the number of nodes, or for example, a fork. No, a fork is a when a blockchain diverges into two potential paths. No, for what it occurs in several cases. When a two nodes resolves the mathematical puzzle that we see previously, at the same time, no? When someone attacks our network, or when the block parameters have been defined incorrectly. As we can see in the picture, if the size of the block increases, the propagation delay increases too. As in the same way, if the block rate increases, the generation delay decreases. Uh, uh, all this makes the security reduced. No, we can create a fork in the simulator too. For it, we are increase the number of the nodes to 10,000. Later, we are reduce the interval of the generation interval of the blocks. And finally, if the block size uh, increase, the security reduced too. Well, we are trying it to generate a fork. Okay, how we can see, we have a orphan, no? Orphan block. Orphan block is a block that is valid and verified, but it has been rejected by the chain because they are product of the fork. No, this reduce our security because the block take two paths. So if you are going for one path, maybe the other is correct, no? And maybe if you are going for other path, the other can be attached. And for this
Okay.
reason, the number of nodes is very important, no? Therefore, if we have not, we need adjust our parameters, no? If I adjust the parameter of the time generation interval, maybe we don't have this scenario. In blockchain, the block generation interval is like 10 minutes. Well, how we can see, we don't have no orphan in this case. Well, for finalize the exposition, we can see no I mean we can test the number of nodes. If I have more nodes, the time propagation is more than if I less nodes. This is a simple graphic of how it's working now. A comparison between normal Bitcoin nodes and the proposed algorithm for the network nodes that are we using in the simulator. It is all about the explication. Thank you.
Muy bien, muy
Okay,
bien, brother.
very good, Brian. Let me make a few questions. I think that it's very interesting. I didn't know the tool, but I have basically I have one question. Because I can create different setups of a blockchain network, and I can use the Ethereum, or I can use the Hyperledger, or I can use any other framework. The simulator has do the simulator have some kind of profile? For example, different setups to Hyperledger or Ethereum, something like that.
Actually, the software hasn't these characteristics, but we can program it. In the code is very simple to understand. We can add another consensus algorithm to prove it. We can add another type of cryptocurrency like it. For example, in this case, the creators are using Bitcoin, Litecoin, and Dogecoin. Give me a second. Simply adding the Ethereum distribution ratio, we can add this cryptocurrency. No, well, we need to change protocols and other things, but not it is impossible, no, to do it.
Okay.